Good evening. My name is teacher candidate Tiffany Welcome, and Miss Ramlal. I will be introducing the first 3 slides of our group assignment for mathematical thinking, which in regards to mathematics in politics, voting, and sampling methods. My group members are inclusive of Mr. Rivaldo Ross, Laura Tulsiram, Ashana Richards, myself, Miss Tiffany Welcome, and Jamila Sicharam. What is democracy? I'll be introducing with. Democracy is a system of government where the people hold the power. The term comes from the Greek word meaning people and power. Citizens use this power by voting either to choose leaders who make decisions for them, representative of the democracy, or to vote directly on a certain issue, direct democracy. Democracy is based on key principles such as individual rights, the rule of law, and the will of the people. It is often described as a government of the people, by the people, and for the people. So, basically speaking, in the introduction here, democracy, it serves the people. People put persons in a position of power whereby they feel their needs and issues are best served, and persons will be able to relate to them and to find and troubleshoot situations and solutions that will ultimately be to the benefit of the citizens. I will now pass you on to my other teacher candidate.
My name is Ms. Jamila Sicharam, and I will be presenting on number 4 to number 10. So starting with number 4, it says, voting impacts our present and future. Now, voting affects not just you, but everyone around you, your family, friends, neighbors, and even future generations. The leaders we choose make decisions about schools, the environment, safety, and the community. When you vote, you help shape the world you and others will live in. Number 5, voting protects human rights. Voting is one of the main ways to protect your rights. When people can't vote, leaders aren't held accountable and rights can be taken away. Voting makes sure everyone's voice is heard so that basic rights stay protected. Number 5, voting is a right and a historical milestone. Not everyone always had the right to vote. Many groups, women, people of color, young people had to fight for it. Voting today honors those who work hard to make sure everyone has a say in decisions. Moving on to number 7. When we don't vote, others vote for us. When you don't vote, the decisions still get made, but by someone else. That means people who do vote decide what happens to your community, your rights, and your opportunities. Number 8, every vote counts. Even though election may seem big, sometimes the difference between winning and losing is only a few votes. These are real examples. Just 1 or 2 votes changed the outcome, so your voice really can make a difference. Moving on to number 9. Voting has financial impact. Leaders who get elected decided how the money is spent on parks, school, taxes, roads, healthcare, and much more. If you want the money to use in ways that help your community, voting is how you influence that. And lastly, number 10, voting is a thoughtful personal act. Voting isn't just checking a box. It's a chance to think for yourself, research candidates, understanding the issues, and choose what you believe is best. It's private, personal, and based on your own values. I will now hand you over to Miss Laura Tulsiram.
Good afternoon, everyone. I'll be presenting on the candidates and the class and the ballot ranking table. The candidates are Crystal, Josiah, Stefan, and Akila. The table displays how 11 students ranked 4 candidates: Crystal, Akila, Josiah, and Stefan in order of preference. Student column, the list of students from 1 to 11, that's the first column. The first choice column shows the candidate each student liked the most. The second choice column shows the student's next preferred candidate. The third choice column shows who they would pick third. Fourth choice column shows the candidate they would prefer the least. From the table, the first 4 students chose Crystal as their top choice. The next 3 preferred Akila, and the remaining students chose Josiah and Stefan as their first choice. The table helps compare how each candidate was ranked across all students.
Hi everyone, good afternoon. So Ms. Laura Tulsiram would have already explained the ballot ranking table, right? So I will be explaining method 1, 2, and fairness and bias discussion. So let's get into method 1. So method 1 deals with plurality. So we have a plurality rule here. Only first place votes matter. So whoever gets the most first place votes wins. Count the first place votes, right? So we have 4 persons participated here. We have Crystal, Akila, Josiah, Stefan, right? So Crystal, 4 first place votes. Students 1 to 4. We have Akila, 3 students, 5 to 7. We have Josiah here, 2 students, 8 to 9. Then we have Stefan, 2 students, 10 to 11. So the winner there, the plurality winner, is Crystal. Then we have method 2 here now. This is a border count, right? So in a border count, we have each position gets points, right? So with 4 candidates, we can assign. We have first place, 3 points. Second place, 2 points. We have third place, 1 point. And fourth place, 0 points, right? So now you can add up these points for each candidate across all 11 students, right? So we have example of how points work for one student. So you can take student 1, Crystal, which is first place, she has 3 points. Akila, second place, she has 2 points. Then we have Josiah here, third place, 1 point. And finally we have Stefan, which is fourth place with 0 points, right? So now you're gonna do that for all 11 students, then add, right? Then we have the final border, right? Then we have the final border, sorry. So we look into fairness and bias discussion, right? So different winners for different methods, fairness debate. So now we have Alex versus Bianca, right? Possible bias, popularity, small samples. Plurality winner, Crystal. So the border winner is Akila, right? So plurality says Crystal should be president. Border method say Akila is better for the whole class, right? It is fair that Crystal wins just because more people put Crystal first, even though most people prefer Akila over Crystal. In one-on-one comparison, border use more information, not just first place, and show that Akila is more widely acceptable. I'll now hand you over to Mr. Shanna Richards to explain further on the PowerPoint. Thank you for listening.
Hi, I'm Jimmy Chang, and we're here to talk about the definition of Arrows and Possibility Theorem. Now, Arrows and Possibility Theorem is used in voting theory, and it's actually a fascinating theorem that goes something like this. When voters have 3 or more distinct alternatives or options, there's no voting system that can convert the ranked preferences of the voters and at the same time meet the specific set of criteria for that particular method. In other words, Arrow's impossibility theorem basically says that if you have 3 or more options, that no voting system is perfect. In other words, every voting system runs into what's known a mathematical impossibility, because no voting system, when faced with 3 or more options, can rank the preferences of individuals and meet a certain set of criteria at the same time. So in other words, what Arrow is trying to say here is no voting system is perfect because the criteria that's being set is going to run into conflict with the ranking of the preferences. So there's a lot more detail to go into that, but Arrow's impossibility theorem pretty much summarizes that in detail. Because what happens is that every method has a certain set of criteria, but as you're ranking those candidates, you're going to run into things that will favor one candidate over another, and therefore you have unfair advantages. So I'm Jimmy Chang, and that's the definition of Arrow's impossibility theorem.
This slide explains Arrow impossibility theorem. It says that when there are 3 or more candidates, no voting system can perfectly fair in every way. In our project, we use the same rankings but got different winners with different methods. This shows that each method has its own limits and no single voting system works fairly in all situations. This project shows us that different voting methods can give different winners, which means no system is perfectly fair all the time. This supports Arrow's impossibility theorem. Overall, we learn how mathematics helps us think about fairness and make better decisions.